Hello and welcome to Cut Saturn 3 2D Disc tutorial. In this video, you will learn how to set 3 cases, including Cut Saturn software and Sayerity software. The latest is dedicated to transient thermal simulations in solid. Do not hesitate to open related PDF file where you will find further details. As usual, I highly recommend you to verify if you have data package for these computation cases. The aim of this tutorial is to simulate the natural convection flow of air inside a sheath containing 3 electric wires. A 2D cross-section of the sheath is considered. Thermal conduction inside the 3 wires is solved with SYRTHES and coupled with the flow solved with Cut Saturn. In the 2 first steps, uncoupled solid and fluid calculations will be set and run separately. Then, a coupled solid fluid computation will be solved. Let's start with Sayerity software. We will create and set a case, then I will show you the results with ParaView. First of all, you need to create both cases, fluid and solid. In order to create cases in the folder, you need to type the following command. In my case, I will have a new folder called 3D 2D Discs into the CFD folder. You will see appearing on the right just after typing the command. And as you can see, the folder just appeared. And if you check subfolders, you will have fluid and solid. In order to launch SYRTHES environment, you first need to load sources by typing sources_SYRTHES. If you need further information, you can check on PDF tutorial. Then you can also type the following command to have the graphic user interface of SYRTHES. This will launch the graphic user interface of solid computation software. Before moving forward, make sure both meshes files are well pasted into their proper folder. For fluid mesh, make sure that the fluid mesh is well pasted into mesh folder, just you see on the screen. And for the solid mesh, make sure it is also pasted into the solid folder. It is called 3run2d.syr. So now create a new data file here by clicking on the icon in order to set a new SYRTHES case. You can also select the solid folder previously created. So case 1 is now open, but you need to set all the settings. We will review together all the settings that need to be filled in order to run the computation. So first of all, you need to type the case title here, 3 2D discs. Make sure the option is 2D card in the main home window. You can also check the mesh, conduction mesh, and make sure that it is also well selected. As you can see, you could also find it in the folder you previously pasted in it. So now you can also, just like Cut Saturn graphic user interface, save your SYRTHES file by clicking on the Save upper icon. It's not an XML document, but an SYD document. So in our case, I called it case 1. We can now move to conduction tab in order to set thermal parameters. So let's first initiate the temperature. So I will initiate 20 degrees in all the solid environment. As you can see, -1 in the reference means everywhere. So you can move to boundary conditions in order to set thermal conditions on external faces of the disk. All these values are available in the PDF tutorial. For this case, only heat exchange tab must be considered. The other tab should not be modified. Let's now move to physical properties and select isotropic, autotropic, and anisotropic in order to set three different fields for each disks. So now, once this is done, you can move to Control tab and under the Time Management header and set the global number of time steps up to 100 and the time step up to 10. The output, you can also create a monitoring point. Here I chose the disk number 1 point located in x.003 and -1.2 following y. You can also check running options, make sure everything by default is okay for you. Then you can run Sayerty's computation after clicking on the Save button. Once you click on the Run Sayerty's computation, a new window will appear, just like you see in Cut Saturn. This is a calculation progress window that gives you information about the computation. We can now move to the next part regarding the post-processing step of this computation. You can load the previous case in ParaView by clicking on the Open icon and then selecting under the Good subfolder, which is Post here, result1.insight.case. This will load the results, and as you can see, there is the sheath, this is the blue disk, and three different disks with each different boundary conditions previously set under Sayerty's graphic user interface. The minimum value of temperature is 20 degrees and the maximum value is 69 degrees. Now we can move on the next computation case with this time Cut Saturn. We will first compute air fluid behavior without solid coupling. I will now set the second cases, which corresponds to the fluid computations uncoupled. So in order to do that, you just need to open Cut Saturn graphic user interface, select the fluid case, and then proceed to the following procedure. So make sure the mesh is well selected. You can also save your XML document. Make sure also all boundary zones are well defined. You will find all these further details in the PDF tutorial too. Regarding calculation features, standard layer and single phase should be ticked. You can select K epsilon linear production, leave 1 meter per second for velocity scales. You can activate the energy equation by selecting temperature Celsius. You can also add body forces, so gravity minus 9.81 following y-axis, and you will be all done for calculation features. Regarding volume conditions, make sure any initialization and physical properties are ticked. You can initialize temperature by clicking here and typing 20. Velocity can be left by default. Physical property, you can add the ideal gas law for the density by clicking here, user law, and typing the following expression. And you can leave all values here by default. and you will be all done for volume conditions. So now move to boundary conditions tab. Make sure all nature are walls. If you select the first wall here, you can add the thermal value 30 degrees here and the exchange coefficient 10 here. No need to change values for the wall BC_2. And now you can select time settings, select time step option constant, reference time step 0.1 and number of time steps 100. Regarding post-processing, you can select writer, results, then you can set the output frequency up to 25. You will be all done for this computation, so you just need to click here on run computation and you will be done for this case. As soon as the computation is done, you can open PowerView and load results fluid domain case. You can select temperature Celsius as a scalar and check if the results are what we expected. In addition, you can also create a slice, and over this slice you can add some streamlines following velocity magnitude. So as follows, you can see the streamlines and fluid behaviors. Remember that this doesn't take into account the 3 solid disks with each boundary conditions. This will be done in the third case we will now set. The aim of this case is to create a coupling computation between solid and fluid. I will now show you how to set the third case of this tutorial. So first of all, you need to open a SYRTHES graphic user interface and make sure all the previous data and settings are well set. So make sure to save a new SYRTHES document. I called here pre-2D disk coupled to make sure that you have two different files, one uncoupled and one coupled. So this time I will set the coupled files. You need make sure the conjugate heat transfer option is ticked. Then we will move to the conjugation to make sure all values are well filled. Fluid, there is no fluid. Physical properties, they are all well filled here. Now you can move to conjugate heat transfer. You need to type fluid regarding fluid case. So it's very important to type the same name case as it was created in the main folder. You can add also references here regarding coupling zones. Control, you need to change time management options and to add number of time steps up to 600. You can also set time step 0.5 seconds. And the output, you can just check if the former probe is still set. So everything seems to be okay. You can save your SYD document and move to the Sayerity graphic user interface in order to configure this time the fluid domain and the coupled computation. So in order to activate Sayerity's coupled computation in Sayerity, you need to go to boundary condition, select the boundary conditions that will be connected with the solid domain. Here it's BC_1. In the thermal window, you just need to select SYRTHES coupling type option and make sure solid is well specified here. So once this is done, you can also save your XML document. You can now move to Coupling Parameters tab, select SYRTHES coupling, then define all the following values. Also, it's very important here to have the same instance name previously typed and the same boundary zones for this case. You can save and move to Time Settings tab. It is very important for this case to set the same time settings options for both software. So that means you need to set 0.5 seconds for reference time steps and the number of time steps up to 600 in this graphic user interface. Regarding numerical parameters, if it's not ticked, make sure improved pressure interpolation is well set. You can now save your case and move to another file that is very important for this case. It is also written in the PDF tutorial and it regards the run.cfg document. This is very important to make sure the computation and the communication between both softwares are well defined. So make sure all the following fields are well filled. So here for the solid domain, you can add the previous case created, so with the name coupled as I created before. You can also add multiple processes if needed, here or here. Once this is done, you can save your document, then you can quit. We will now run the computation. So in order to do that, you need to open a terminal in the same window, in the same folder. You need to load SYRTHES sources as we did before. Then you can type cut_saturn run. This refers to the run .cfg file. Then you can press enter. The computation could be quite long, so I will cut the video and come back once this is done. So now the computation is done and we will move to the post-processing step. So in order to process all the results for last case, you need to open ParaView and load both results, solid and fluid. In order to do that, make sure to select both results in the result coupling folder by clicking here, selecting the last computation. Then you have two subfolders, the solid one and the fluid one. You need to load both in order to see interaction between the solid domain and the fluid domain. So once you do that, and as I did, here is the fluid domain and here is the solid domain. As you can see, solid domain is well initiated, down 20 degrees up to a maximum of 62 degrees Celsius, while the air is at 20 degrees Celsius. So let's now check if the computation ran well. So as you can see, you have the evolution of temperatures in the sheath. Wires create interaction with fluid, hair fluid, and as you can see, the air is heated. You can also, if you want, check the streamlines, velocity streamlines, by creating streamlines here. In order to do that, we need to reduce opacity of the domain, and as we can see here, streamlines appears. You can also improve your skills by checking other scholars and creating all post-processing data as needed for this computation. A good exercise will be to find the same results as we have in the PDF tutorial. This concludes this video tutorial. I really hope you enjoyed watching this video. I highly recommend you to keep tracking Sayerity updates by checking on our channel or social media pages to get the latest news. Thank you for watching.